If you want to improve your database design skills, keep watching as I design a database for a real estate company. This company is responsible for listing properties for sale or for rent, keeping track of the people who show interest and attend inspections, and recording sales. Let's get started. Just like with my other videos, we'll look at each of the requirements we want to design for, then show how we will capture that on the diagram. Our first requirement is this. We want to capture information about properties, including the address, the type, size, and a few more attributes. If you've ever browsed a website that shows properties for sale, this might seem familiar to you. Let's get started with a diagram. Here is a new blank diagram. For the keen observers among you, something may look different. If you've seen any of my other database design videos, you'll notice this looks a lot different, and you would be right. I've started playing around with a new database design tool called DB Diagram. It's got a range of cool features, and the way you create a diagram is by typing text on the left panel and the diagram is drawn. I'll have a separate video on this tool and how to use it in the future, but I just wanted to point that out. So let's start with our diagram. We'll add a new table for a property. We'll give it an ID field and make it the primary key. This is to uniquely identify the record, and you can call the column whatever you like, but I usually call it ID. For the address, we could start adding the fields such as address line 1 and region. Normally I have a separate table for addresses, but given that we're describing something that sits at an address, I think it's okay to include it in this table. The city stores the city of the property and the region stores the state or province. The next thing to add would be a country, but we can assume for this company they are only operating in one country. If you want to add a country, you can. You can see that as we add the text here in the left panel, the table on the diagram panel on the right is automatically updated. What else do we need? The next was the type of property, such as house or apartment. Anytime there is a value that is one of a range of values, I like to create a separate lookup table for them and link to this table. So that's what we'll do now. I'll add a new table called property type and give it an ID as a primary key, and a description field that stores values such as house or apartment. I'll add a note here, which we can see on the diagram when we hover over the table. I'll add this ID to the property table. How can we add the foreign key? In DB Designer, we add a line at the bottom starting with ref, then the two columns and an arrow like this. The diagram is updated with a line between the two columns. I'll rearrange the tables a little bit to make it easier to see. What else do we need to store? The other attributes were the property size, the block size, a number of bedrooms and bathrooms, the number of car spaces, and a description. We've added all of those to the table, and we can say that requirement 1 is met. Requirement 2 is about the property being listed as either for sale or for rent. It also has several steps in this process. Let's update our diagram. To store the fact that a property is either for sale or for rent, we can create a new table. I'll call it listing_type. I'll add an ID and a description and a note to say what it can be used for. I'll add a listing type ID to the property table to capture the listing type for the property. Then I'll add a foreign key to link the two tables. We can see our diagram has been updated. Now let's add that process or status. Just like with the property type and listing type, I'll add a new table for the status values of the property, because it can be one of a few different values. I'll also add a foreign key so the tables are linked, and rearrange the diagram a little. We can see the diagram is now updated and that requirement number 2 is met. Requirement 3 is where a property can have a price which is either a sale price or a monthly rental price. There are a couple of ways I think we can do this. First, we'll need a price column, so we'll add that to the property table here. The requirement says that we need to store either a sale price or a rental price. Do we need a second price column? We could, but then we would have to enforce one or the other being specified, either a sale price or a rent price. We could have a price type to indicate if it's a sale price or a rental price. But we already have something similar, the listing type. I think we can assume if the property is for sale, the price represents the sale price, and if it's for rent, the price is the rental price. So, with just this price column, the requirement 3 is met. Requirement number 4 mentions that a property can have different features, such as a washing machine or a carport. We want to be able to store which of these features exist for a property. We can assume there is a set list of features and some or all of them apply to a property. On our diagram, we would need to have a table to list all of the features that exist. We can create a table called feature that has an ID and a feature name column. We'll add a note to say what the features are for. Next, we need a way to relate it to a property. A property can have many features, and a feature can exist in many properties. This is a many-to-many relationship, so we need a joining table. I'll add a joining table here called property feature that has the IDs of both the property and feature tables. Then I'll add 2 lines of text for the foreign keys for these tables. I'll rearrange the diagram like this, and we can see that features are now captured. Requirement 4 is now met. The next requirement says that a property can go through this process multiple times, such as getting sold and then leased. That's interesting. So a property could be listed for sale and then in the future it can be listed for rent, or some other combination. Let's see our diagram. On our diagram we have the property table with all of this information. Most of the columns describe the physical property, such as the address and the number of bedrooms. There are some columns that actually describe the listing of the property, such as the type of listing and the price. If a property is listed multiple times, then these values could change. We would then lose the original values. We don't want to have one property record each time it's listed because that would be duplicating data. What can we do? We've actually stored 2 pieces of information in this property table, a property and a listing. We should separate the listing, which is the information about a property being listed for sale or rent, into a separate table. Let's do that now. We'll create a new table called listing. We'll have an ID, the property ID that is being listed, the status of the listing such as listed or completed. We can also add the listing type and the price. Let's rename this property status table and field to listing status, as it refers to the status of the listing. Let's also add a date to indicate when the listing was created, so we can see when it was added if a property is listed multiple times. We've got the table and now we need to update the foreign keys. We'll adjust the section at the bottom here that lists the foreign keys so they point to the right tables. Finally, we'll rearrange the diagram to make it clearer. So requirement 5 is now met, with the addition of this listing table. The next requirement, number 6, mentions employees that can work on the property being listed in a variety of roles and over different time periods. Let's add this to our diagram. We haven't mentioned anything about employees yet, so let's add a table for that. We'll just add an ID for now, but we can always add more fields later. How is it related to a listing? An employee can work on many properties, we can assume, and a property can have many employees. So it's a many-to-many relationship. Let's add a joining table between listing and employee. We'll add the IDs of each table, then add some text at the bottom to refer to the foreign keys. What else do we need to do? Well, the requirement says that an employee can work in different roles. We can assume there's a defined list of roles, such as selling agent or property manager. These roles would then be related not to an employee, but to an employee working on a listing. This is because they could have different roles on different listings. So we'll add a role type table with an ID and a description of the role. We'll also add a note to further describe the table. We can then add a role type ID to the joining table of property and employee, which links to the role type table. We've now captured the role of the employee working on the listing. The last point is about different time periods. This is a common requirement when storing things in tables. The idea of having different records apply for different periods. A good way to achieve this is to have the concept of an effective date. This means having a start date and an end date for each record. A start date records when something is effective from, and an end date records when it is no longer applied. If the end date is null, it's currently active and ongoing. So we can update our property employee table to add both a start date and end date column. You could also call it effective from and effective to, or something else, so it's up to you. Requirement number 6 is now met. We're almost there. Requirement 7 out of 11 is about employees. We want to know a bit about employees such as their name, dates and job title. Let's update our employee table. We can add a few fields to it, which are first name, last name, start date, end date and job title. The start date and end date store when their employment started and finished, which is different to their role on a property listing. With these columns added, requirement 7 is now met. Requirement 8 of 11 is about inspections. A property can have multiple inspections and each of them has an employee which would be to organise the inspection. We can achieve this by adding a new table called inspection. We'll add an ID as the primary key. We add a link to the property that is being inspected. We could add a link to the listing, but the listing can be found from the property, and I think the property is what's being inspected. We can capture the date and time of the inspection, and then the employee ID that's responsible for the inspection. We'll add in a couple of foreign keys for the property table and employee table. Then we rearrange the diagram and there we go. Requirement number 8 is now met. Requirement 9 is about clients. We want to capture clients and some information about them, such as the properties they are interested in and the inspections they have attended. So we'll add a table for clients. We'll add an ID, their name, email address and phone number. We need to relate them to properties and to inspections. How are they related? A client can be interested in many properties, and a property can get interest for many clients. So it's a many-to-many relationship. Let's add a joining table for this. Then we add foreign keys at the bottom. We can move the table on the diagram so it's easier to see. Now what about inspections? I think the same concept applies. A client can attend many inspections and an inspection can have many clients. So we'll add another joining table along with the foreign keys. We then rearrange the diagram. We can see we have captured clients, the properties they are interested in, and the inspections they have attended. So requirement 9 is now met. The second last requirement, number 10, is about recording offers that a client makes for a property. The offer can be accepted or rejected, and multiple offers can be made. In our diagram, we want to record information about the offer. We want to record who the client was that made the offer, what property it's for, and the amount. We also want to record the status of the offer, such as accepted or rejected. However, that's better recorded in a lookup table, like we have for many other tables. So we can create a lookup table for the offer status with an ID and a description. We then add the status ID to the offer table. Next, we'll add some foreign key references to this list here, then rearrange the diagram to make it look better. Why do we relate the offer to the property and not the listing? I think it's because the offer is more related to the property. But at the moment, I can't think of a strong reason to relate it to one instead of the other. If we were to develop this system and found that we wanted to capture the data in a way that wasn't supported, we could change our design to handle it. For now, requirement 10 is met. The last requirement is about when a property is sold or leased. We want to store information about the contract and the transaction, the clients, the employees involved, dates and a status. Let's add this to our diagram. We'll add a table called contract. What columns do we want to add? We'll add an ID for the primary key. Next, the property ID for the property that is sold. We want to store whether it's a sale contract or a rental contract. We have this in the listing type table, so we can store an ID of that table here. Next, we'll store the contract document, and more specifically a link to the document which can be stored elsewhere. We can store the ID of the employee that is responsible for the contract. We can store the client that is involved in the contract. We'll store the signed date of the contract and the start and end date. The contract status is a defined list of values, so we'll create a separate table for the contract status with an ID and description. We'll add an ID for this table in the contract table. Then we add some foreign keys for these tables at the end. Finally, we'll rearrange the tables, which could take a bit of time because we have a lot of tables and relationships now. And now, requirement 11 is now met. We've met all of the requirements for our database. We can see our database design here. We've got quite a few tables. Many of them are linked to the property table, which is kind of a central table. We've got a few relationships to clients, contracts and offers, but we've achieved all of our requirements. You might be looking at this and thinking of a few scenarios it doesn't handle. What if a client is a combination of two people, such as a couple who want to rent or buy a house? Our design doesn't handle that, but it could be updated to cater for it. What if there are multiple employees for an inspection or a contract? The design doesn't handle that either. The concept of a client being interested in a property and inspecting it and making an offer, then a contract, seems like different stages of a process. Maybe there's a way to combine a few tables. So those are just some things that this database doesn't do, or some ways the design could be changed. If you notice anything you want to do differently, feel free to update the design. Check out some of the other videos on my channel on database design, such as this one here about designing an e-commerce database. Thanks for watching.